Welcome to BIM and AI in Practice. We're excited to have you back for the third episode of our Revit 2025 series. Today we're going to dive deeper into one of the core sections of Autodesk Revit, the Architecture tab, your central hub for all architectural workflows within the software. If you haven't had the chance to check out the first two episodes yet, now's a great time to do so. In those videos, we covered key architectural panels that will serve as a strong foundation for today's more advanced exploration. Whether you're an intermediate user or just starting to dive into the software, you'll find practical insights that will enhance your proficiency and elevate your Revit skills. Even if you're a seasoned professional, there's still plenty of value in optimizing your workflows and fine-tuning your technical expertise. And don't worry, engineers and construction professionals, we've got you covered too. We'll be releasing dedicated tutorials focused on the Structure tab and other industry-specific tools in the near future. So be sure to check back regularly for fresh, in-depth content to expand your BIM knowledge. Remember, a strong architectural foundation not only enhances your technical proficiency, but also improves your problem-solving skills and fosters innovation in your designs. This is essential for creating spaces that are functional, sustainable, and visually compelling. In today's fast-evolving industry, embracing tools like BIM and AI is crucial for staying ahead of the curve and driving design excellence. Now, let's dive right in and continue our journey through the Architecture tab. Today, we'll explore one of its most powerful features, the opening panel, which plays a key role in streamlining your workflow and expanding your design possibilities. You can use the opening by face or vertical opening tools to create precise openings in various elements, including walls, floors, ceilings, roofs, structural beams, braces, and columns. When it comes to cutting openings in structural beams, braces, or structural columns, we'll cover that in a dedicated video focused on openings in structural elements. Similarly, openings in structural floors and decks will be addressed in our upcoming videos on openings in structural floors. Additionally, when creating a family, you can also sketch openings directly into the family geometry. First, select the Architecture or Structure tab and navigate to the opening panel. From there, choose either by face or vertical. Use the by face option when you want the opening to be perpendicular to the selected face, such as a wall or roof. Opt for vertical if you want the opening to be perpendicular to a specific level, like in a floor or ceiling. Next, once you've selected the appropriate option, you'll be prompted to choose the element where you want to create the opening. If you chose by face, simply select a face on the floor, ceiling, or roof. If you selected vertical, pick the entire element, such as a wall or floor slab. Then Revit will enter sketch mode, allowing you to freely draw and customize your opening, creating any shape you need to fit your design requirements. Finally, once you're satisfied with your sketch, click Finish Opening to finalize the cut. Pro tip: in sketch mode, if you need to adjust the opening, you can either move the entire sketch or modify individual line segments to fine-tune the shape. Simply select the sketched element and make your adjustments as needed. important note. When cutting an opening in a wall, keep in mind that you can only create rectangular openings in straight or arc walls. For walls, only rectangular openings are allowed. You won't be able to create round or polygon shapes directly. To cut round or polygon openings, you'll need to use the Edit a Wall Profile tool instead. Now let's walk through the process of adding an opening in an arc wall. First, open a view that allows you to access the wall where you plan to place the opening. Next, select the wall that will host the opening and click on Wall Opening from the opening panel. Then, sketch a rectangular opening. Keep in mind that when creating an opening in a slanted or curved wall, the resulting opening will not be perfectly rectangular due to the wall's geometry. This is an important consideration to remember when working with complex wall shapes. With the sketch, click Finish Sketch to complete the process. To further modify an opening, you can use the drag controls to adjust both the size and location of the opening. Simply click on the opening, and you'll see the drag handles appear, allowing you to resize or reposition it as needed. Additionally, you can drag the opening to a new location along the same wall. This flexibility allows you to make quick adjustments to your design. If you want to precisely control the opening's position, you can also add dimensions to the opening to ensure accurate placement and alignment within your design. Now let's dive into another powerful tool, the shaft opening tool. This allows you to create an opening that extends through the entire height of a building or selected levels, cutting through roofs, floors, ceilings, or toposolids simultaneously. First, click on the Shaft button in the opening panel and begin sketching your shaft opening. You can do this by either drawing lines or picking walls. Typically, you'll want to sketch the shaft on a host element, such as a floor, in plan view. Next, if desired, you can add symbolic lines to represent the shaft visually. These lines won't cut through elements, but will help indicate the shaft's location in your view. Then, once you're satisfied with your sketch, click Finish Opening to complete the process. Fourth, if you need to adjust the levels through which the opening cuts, select the shaft opening and make the necessary adjustments in the Properties palette. For base constraint, specify a level for the start point of the shaft. For top constraint, specify a level for the end point of the shaft. Finally, the shaft will cut through all levels between the specified start and end points, and it will be visible on all intermediate levels. If you move the shaft on any level, it will automatically adjust on all levels. The symbolic lines will also be visible on all levels, providing a clear indication of the shaft's location. Quick question for you. What do you think is the most challenging aspect of working with openings in Revit? Is it the precision, the different types of openings, or something else entirely? Drop your thoughts in the comments below and let's chat. And don't forget to hit that like button if you're finding these tips helpful. Now let's move on to the next task. Creating a dormer opening in a roof. This process is a bit different, but equally important for customizing your design. First, create the walls and roof elements that will make up the dormer. You can use the same approach we've previously discussed for handling these tasks, ensuring that the elements are properly positioned and aligned within your design. Once the basic structure of the dormer is in place, you can proceed with creating the dormer opening in the roof. Now that we've covered the ins and outs of opening creation, let's move on to another key aspect of building design in Revit: levels. Levels are finite horizontal planes that serve as references for level-hosted elements, such as roofs, floors, and ceilings. They define key elevations within your building model. Typically, you'll create a level for each known story or other significant reference points within the building, like the first floor, top of wall, or bottom of foundation. Now, let's take a look at how to add levels in your Revit project. First, open the section or elevation view where you want to add levels. Then on the ribbon, click Level. You can also find this option in the Datum panel of the Structure tab. Second, as you move the cursor to place a level, you'll notice that if the cursor aligns with an existing level line, a temporary vertical dimension will appear between the cursor and that level. This helps ensure accuracy when placing the new level. Simply click to place the level at the desired location in the drawing area. Next, draw the level lines by moving the cursor horizontally. You'll notice that the Plan View option is enabled by default in the Contextual tab of the ribbon. This means that each level you create will automatically be associated with a story level, including a floor plan view and a reflected ceiling plan view. If you want to customize which plan views are created, click on Plan View Types in the Options bar. This will allow you to choose specific view types to generate in the Plan View Types dialog. If you uncheck Make Plan View, the level will be treated as a non-story level or reference level, and no associated plan views will be created. However, you can still use reference levels as constraints for walls and other level-based elements. As you draw level lines, the heads and tails of the lines can automatically align to one another. When a level line is aligned with others, you'll see a lock icon appear indicating the alignment. If you move one of these level lines horizontally, all the aligned level lines will move with it, maintaining their relative positions. You can adjust the height of the level by clicking on the dimension next to it. Similarly, you can easily change the name of a level by clicking on the number next to it to select it. If you prefer, you can also rename the level using the project browser. When you rename a level or a view, a dialog box will appear asking if you want to rename the corresponding level and/or plan views. 1. If you rename the level, Revit will prompt you with a dialog asking if you'd like to rename all the associated views with the same original name. If you click Yes, Revit will automatically rename all views that match the original name of the level. 2. If you rename one of the views, e.g. a floor plan view that shares the same name as a level, the dialog will again ask if you want to rename the corresponding level and all related views. Clicking Yes will rename the level and any views that share the original name. When you delete a level in Revit, it also removes any associated views and model elements that are hosted by that level, such as doors, furniture, and rooms. Before the deletion is finalized, Revit will display a warning message listing all the items that will be deleted along with the selected level. This gives you an opportunity to review the affected elements and cancel the deletion if needed. If deleting doesn't have any associated views or hosted elements, Revit will not issue a warning and will delete the level immediately. You can move a single level or multiple levels in elevations, sections, and 3D views. First, in an elevation view, section view, or 3D view, select the level you want to move. Next, you have a few options for moving the level. 1. Drag the level up or down in the view. 2. In the Properties palette, under Elevation, enter a new value to adjust the level's position. 3. Click a dimension length between levels and enter a new value to change the spacing. You can modify level type properties, such as elevation base and line weight, in the Type Properties dialog. To change these properties, select the level element and click Type Properties. Any changes made to type properties will apply to all instances of that level within the project. Within the Type Properties dialog, you have control over the following settings. Line pattern. This controls the appearance of level lines. You can choose from solid lines or a combination of dashes and dots. Revit provides a list of predefined patterns, or you can define your own custom line pattern. Symbol. This determines how the head of the level line displays. You can choose to show a level number inside a bubble, level head, circle. Show just the level number without a bubble, level head, no bubble. Or choose not to display any level number at all. In our upcoming lectures, we will dive deeper into how to create custom symbols and line patterns for more personalized and flexible designs. You can modify instance properties to specify various settings for a level, such as its elevation, computation height, name, and more. To change these properties, simply select the level element and adjust its settings in the Properties palette. For example, the computation height defines the distance above the level used when computing a room's perimeter, area, and volume. Revit calculates the perimeter of a room at this defined height above the base level of the room. By default, the computation height is set to 0 or 0 millimeters above the base level. This default setting works well for buildings with vertical walls, as it usually provides accurate results. However, for buildings with sloped walls or other unique features, you may need to adjust the computation height to get more precise measurements for room areas and volumes. Levels in elevation or section views. You may want to offset the level label from its level line for better clarity. First, locate the end of the level line near the bubble. It will have drag controls. Select and drag the end control near the bubble to resize the level line as needed. Second, click the Add Elbow Drag control, and then drag it to the desired location to move the bubble away from the level line. With a solid understanding of levels in place, we can now move on to the Grid tool. You can use the Grid tool to place column grid lines in your building design. Once the grid lines are in place, you can add columns along them. Grids can be straight lines, arcs, or multi-segmented, and you can hide the grid lines after they've been placed if desired. Grids serve as annotation elements that help organize your design and provide a structural framework for placement of elements like columns. First, on the Architecture or Structure tab, click Grid. Second, in the Draw panel, select a sketch option. 1. Pick lines. Use this option to snap the grid to an existing line, such as a wall. 2. Multi-segment. This allows you to sketch grids that require more than one segment. Now draw grid. Revit automatically numbers each grid. To change a grid's number, simply click the number, enter the new value, and press Enter. You can also use letters for grid line values. For instance, if you change the first grid number to a letter, all subsequent grid lines will automatically update accordingly. As you draw grid lines, the heads and tails of the lines can align with each other. If grid lines are aligned and you select one, a lock icon will appear to indicate the alignment. If you move the extents of a grid, all aligned grid lines will move together, maintaining their relative positions. Grid line properties, such as the line style for the center segment or the symbol used for the ends of the grid line, through the Type Properties dialog. To change type properties, select a grid line element and click Type Properties. Any changes made to type properties will apply to all instances of that grid line within the project. Here are a few key properties you can adjust. Symbol. This controls the symbol used for the ends of the grid line. You can choose from Grid Head Circle displays a grid number inside a bubble. Grid Head No Bubble displays just the grid number without a bubble. No grid number or bubble is displayed. End segment pattern. This defines the line style for the end segments of a grid line. If the center segment is set to none or custom, this setting controls the line style for the end segments. Plan view symbols end 1 default. In a plan view, this setting determines whether a bubble is displayed at the start point of a grid line. By default, a bubble is shown at the start of each grid line. If needed, you can show or hide the bubbles for individual grid lines in specific views. Grid instance properties. You can modify properties for individual grid lines, such as the name or scope box, through the instance properties. Name. This is a value assigned to the grid line, which can be numeric or alphanumeric. By default, the first grid line is named 1, but you can change it to any other value that fits your project's needs. Having established the grids, we can now proceed to the work planes. A work plane is a virtual two-dimensional surface used as the origin for views or for sketching elements. A work plane is used in several ways within Revit. One is the origin for a view. It provides a reference for the placement of views in the project. 2, for sketching elements. Work planes are essential when sketching certain elements that need to be aligned to a specific plane, such as creating complex shapes. 3, for enabling tools in specific views. Work planes allow tools like rotate and mirror to function in 3D views, enabling more accurate manipulation of objects. 4, for placing work plane-based components. Some components are hosted directly on a work plane, which helps with accurate placement and alignment. Work plane and views. Each view in Revit is associated with a work plane. For example, a plan view is linked to a horizontal work plane, typically a level. An elevation view is linked to a vertical work plane. In some views, such as Plan 3D and drafting views, as well as in the Family Editor, the work plane is set automatically. However, in other views like elevation and section views, you will need to manually set the work plane. When you set a work plane in a view, it becomes saved with that view, and you can change it at any time as needed. The work plane is essential for sketching operations, such as when creating an extruded roof or other elements that need a specific reference surface. While sketching, you can snap to the work plane grid to help guide your design. However, it's important to note that you cannot align or dimension directly to the work plane. Selecting a work plane. You can select a work plane in Revit by name, by picking a plane, or by picking a line within the desired plane. First, go to the Architecture, Structure, or Systems tab and in the Work Plane panel, select Set Work Plane. Second, in the Work Plane dialog, under Specify a new work plane, choose one of the following options. Name. Select a predefined work plane from the list and click OK. Pick a plane. Create a work plane coincident with the selected plane. Choose this option, then click OK. Move the cursor over the drawing area to highlight available work planes, and click to select the desired plane. Pick a line. Create a work plane that is coplanar with the work plane of the selected line. Choose this option, then click OK. Move the cursor over the drawing area to highlight available lines, and click to select one. Show the work plane of a view. To display the work plane in your current view, simply click Show. Once activated, the work plane will appear as a grid within the view, giving you a visual reference for your sketching and modeling operations. Add a reference plane in Autodesk Revit. Using the reference plane tool is an essential step in creating accurate and organized designs within Revit. Reference planes serve as guidelines, providing you with a visual framework to position and align elements in your model. They play a crucial role in family creation, appearing in each plan view that you generate for your model. Finding the reference plane tool. You can locate the reference plane tool across multiple panels, not just within the Architecture tab. It's available in the Work Plane panel of the Architecture, Structure, and Systems tabs, and also within the Family Editor. This versatility ensures you have access to this tool wherever you are working. Drawing a reference plane. First, to draw a reference plane using the Line tool, navigate to the Draw panel and click on Line. In the drawing area, drag your cursor to create the reference planes. This is the most straightforward method for placing them. Next, if you prefer to pick an existing line, you can use the Pick Lines tool. Simply click on Pick Lines in the Draw panel. On the Options bar, you can specify an offset if needed. Then, move your cursor near the line you want to align with and click to place the reference plane. Naming your reference planes. To keep your project organized, it's important to name each reference plane. Doing so allows you to easily assign it as your current work plane when needed. To name a reference plane, simply select it and go to the Properties palette. In the Name field, type in a name for your reference plane. Alternatively, you can click directly on the text label of the reference plane in the drawing area and type the name there. By naming your reference planes, you create a clearer, more organized workflow for your design process, improving both efficiency and accuracy. Assigning a subcategory to a reference plane to better manage visibility and graphic settings in your Revit projects. You can assign a subcategory to a reference plane. This allows you to control how reference planes appear in your model, making it easier to distinguish between different types of reference planes, especially in complex views and families. Using subcategories, you can customize line colors and line styles, providing clarity and organization to your design. Creating a reference plane subcategory. First, select the reference plane you wish to modify. Second, navigate to the subcategory panel. And from the subcategory list, choose Create New Subcategory. Next, the New Subcategory dialog will appear. Here you can enter a name for your new subcategory and click OK. Finally, customize the line color and line pattern to your preference. Once done, click OK to apply the changes. By assigning subcategories to your reference planes, you not only improve the clarity of your model, but also enhance the overall organization and visual hierarchy, making it easier to navigate complex designs and models. Now that we've defined our reference planes, let's shift our focus to the workplane viewer. Using the workplane viewer to modify workplane-based elements. The workplane viewer is a valuable tool for adjusting workplane-based elements within your model. This temporary on-the-fly view allows you to interact with your design elements without permanently altering your project's structure. Keep in mind that the workplane viewer is not listed in the project browser, making it a transient view that only appears when activated. Workplane viewer. The workplane viewer can be accessed from all model views within the project environment. Its default orientation will align with the active workplane of your last active view. This ensures that you're always working in the correct context and allows you to modify elements based on the most relevant workplane. Architectural education, merging creativity with problem solving. Architectural education is about more than just mastering design principles. It's about blending creativity with critical problem solving skills to create spaces that have the power to shape our world. The tools we use, like Autodesk Revit 2025, are not just software, they're extensions of our creative process. They help us transform abstract concepts into practical, functional structures, making our visions come to life. Thank you for joining us for Part 3 of our Revit 2025 series. We've covered a lot of ground, and we hope you found the insights valuable. If you missed Part 1 and Part 2, be sure to check them out. They provide the foundation for everything we've discussed today. And don't forget to tune in next week, where we'll explore even more advanced features of Revit, helping you refine your skills and optimize your workflows.